Sugar. We're told it's the enemy. It's in everything, and we hear a dozen different names for it: glucose, fructose, sucrose, high fructose corn syrup. What's the difference? Is the sugar in an apple the same as the sugar in a can of soda? And what about those sugar-free sweeteners? It's confusing, but it doesn't have to be. Let's break down every type of sugar you'll encounter. First, the absolute foundation: glucose. Think of glucose as your body's primary currency for energy. It's the simplest form of sugar, and it's the main fuel source for your brain, muscles, and every cell in your body. When you eat carbohydrates, your body breaks them down into glucose, which then travels through your bloodstream to provide immediate energy. This is what people are measuring when they talk about blood sugar levels. When your blood sugar rises, your pancreas releases insulin to help shuttle that glucose into your cells for use. It's essential for life. You can find glucose in foods like bread, pasta, and rice, but it's also present in honey and fruits, usually paired with other sugars. Next up, fructose. This is famously known as fruit sugar. It's the sweetest of all naturally occurring sugars. Unlike glucose, which enters the bloodstream directly, fructose takes a different path. It has to be processed almost exclusively by your liver. In its natural form, like when you eat an apple, fructose comes packaged with fiber, water, and vitamins. The fiber slows down its absorption, preventing your liver from being overwhelmed. However, when consumed in large, concentrated doses, like from sugary drinks, it can put a significant strain on the liver, which over time can contribute to health issues. So, what happens when glucose and fructose team up? Sucrose is the scientific name for what we all know as table sugar. It's a disaccharide, which is a fancy way of saying it's made of two smaller sugars bonded together, one glucose molecule and one fructose molecule. It's 50% glucose, 50% fructose. When you eat sucrose, your body's enzymes quickly break it apart into its two components. The glucose part causes a rapid spike in your blood sugar, while the fructose part heads straight to the liver for processing. So, you get the effects of both at the same time. Sucrose is naturally found in sugarcane, sugar beets, and maple syrup, but it's most famous for being the white, granular stuff you put in your coffee. Now for the sugar in dairy, lactose. Lactose is a sugar naturally found in milk and dairy products. It's another disaccharide made up of one glucose molecule and one galactose molecule. In order for your body to use it, it needs an enzyme called lactase to break the bond between the two. If your body doesn't produce enough lactose, the lactose can't be broken down properly, and it ferments in your gut. This is what causes the bloating, gas, and discomfort known as lactose intolerance. It's a perfect example of how your body's ability to process a sugar is just as important as the sugar itself. Let's talk about a lesser known one, maltose. Maltose is also called malt sugar. It's another disaccharide, but this one is formed from two glucose molecules bonded together. It's less sweet than table sugar and is most commonly formed during the process of germination or malting, which is why it's a key ingredient in making beer. Since it's made of pure glucose, when you consume it, your body breaks it down into glucose, causing a significant spike in blood sugar. You won't find it in many whole foods, but it's present in molasses, some cereals, and certain cooked starchy vegetables like sweet potatoes. Now for the industrial giant, high fructose corn syrup. This is a big one. High fructose corn syrup, or HFCS, is a man-made liquid sweetener derived from cornstarch. Unlike sucrose, where glucose and fructose are bonded, in HFCS they are separate individual molecules. It's incredibly cheap to produce and mixes easily into beverages, which is why it became the go-to sweetener for the food industry. The most common form is HFCS 55, which is approximately 55% fructose and 45% glucose. Because the fructose is free and not bonded, it's absorbed very rapidly, placing a heavy, immediate load on the liver. It's found in countless processed foods, from soda and candy to ketchup, salad dressings, and even bread. This brings us to an important concept: added sugars. This isn't a type of molecule, but a category. Added sugars are any sugars or syrups that are put into foods during processing or preparation. This is the single most important distinction in the world of sugar. The naturally occurring fructose in a whole orange is not the health concern. The concern is the massive dose of added sucrose, or HFCS, in a glass of orange-flavored soda. Health organizations recommend strictly limiting added sugars because they provide empty calories with no nutritional benefit and contribute directly to major health problems. They hide under dozens of names on ingredient lists like dextrose, cane juice, and agave nectar. Always check the added sugars line on the nutrition label. What about the fake sugars? Let's talk about artificial sweeteners. These are synthetic man-made chemicals that are hundreds or even thousands of times sweeter than sucrose. Common examples include aspartame, sucralose, and saccharin. Because they are so intense, only a tiny amount is needed. They provide 0 calories and do not raise blood sugar levels, which makes them popular in diet and sugar free products. However, they are a source of ongoing debate. While they don't impact blood sugar, research continues to explore their long term effects on our gut microbiome, cravings, and overall metabolic health. Finally, we have sugar alcohols. You'll recognize these by their names: xylitol, sorbitol, erythritol. These are a type of carbohydrate called a polyol. They are a hybrid with a chemical structure that's part sugar and part alcohol, but not the kind of alcohol that gets you drunk. They are less sweet and have fewer calories than regular sugar. Your body doesn't absorb them completely, so they have a much smaller impact on blood sugar. But because they aren't fully digested, if you consume too much, they can ferment in your gut and cause digestive side effects like gas and bloating. You'll find them in sugar-free gum, candies, and protein bars. It's not about avoiding sugar entirely. It's about knowing which types you're eating and understanding that the source matters most. And that's every type of sugar, explained simply. Subscribe for more science.